Okay. So we are going to start 10.4. Use inscribed angles and polygons. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. So inscribed angle is when it's on the inside of the angle, and then this is the intercepted arc in red right here. So our first theorem, you can either pause the video and copy this into your notes or come back to the myhrw.com and copy it into your notes for the tests and the quizzes. So theorem 10.7, measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So what the theorem tells us is if we want to know the angle right here on the inside, whatever this arc measure is, the angle is going to be exactly 1/2. And then these are the 3 different scenarios that happened for the inscribed angles. Make sure you copy that into your notes, the 3 different cases. And then we're going to look at example 1. So example 1 gives us a picture of a circle, which I am going to now draw. So here we have this circle with these angles. So I drew my circle. The first thing that we're looking for is the measure of angle T. And then for B, they want us to find the arc length of QR. So they give us this inside angle of 50 degrees, and then they give us this arc length of 48 degrees. So to do the first part, the measure of angle T. So we want to know, I'm going to use a different color. So they want to know this angle right here. Well, according to our theorem, it says that the inside angle is exactly 1/2 of the arc length. Since they give us the arc length to be 48, to know what this angle is, we're going to divide by 2, and that gives us 24 degrees. So the measure of angle T is 24 degrees. Now we're going to figure out this arc length right here. Well, we don't have anything that directly links it to that, so we have to use this angle right here. Well, by using this angle, I'm going to use another color again. Well, if this is 50, using the theorem, conversely, going the opposite way, if this is 50, that means this arc length has to be double that. So this is 100. So arc TQ is 100. Well, since TR goes through the center of our circle, that means it's halfway, it represents the diameter. So that means this whole length from TQR, so TQR itself has to equal 180. Since TQ is 100, to know this one piece right here, which is QR, which is what we're looking for, well, we're going to take 180 minus 100, and that gives us 80. So that means this is 80 degrees. That arc length for QR is 80 degrees. So that's our first example. Now we're going to move on to example 2. Before we do that, we're going to look at theorem 10.8. It's actually going to help us with example 2. So theorem 10.8, it says, if two inscribed angles of a circle intersect the same arc, then the angles are congruent. So it shows us the picture here. So that means angle D and angle C are congruent to each other. That's going to help us with example 2. So for example 2, it gives us this circle, which I'm going to draw with these inscribed angles inside. T, R, U. Drew my circle there. So they want us, the first thing they want us to find is the measure of arc RS, and then to find the measure of angle STR. Well, the piece of information that they give us is that this is 31 degrees. So let's find our first part, the measure of RS. So it wants to find this angle. Well, if you notice, it references this right here. So it goes back to theorem 10.7 over here with this inside angle, this arc length, if they give us this angle, this arc length is going to be double that. So 31 times 2 is 62. So that arc length is 62 degrees. Then we want to find STR, the angle of STR. So angle STR. Well, according to this theorem here, these two inscribed angles of a circle that intercept in the same arc are congruent. So if this is 31 degrees, this angle right here has to be 31 degrees. For example 3, I'm not going to draw it. Since it's multiple choice, I'm just going to read through it. Why is it my pen? There it is. So it gives us this circle with inscribed angles, and it wants us to name 2 pairs of congruent angles in the figure. Well, when it gives you the 3 letters, remember that middle one is always going to refer to the angle itself. It's a little not focused. Let's focus it a little bit. Let's see. There we go. So the first one says JKM. So JKM is referring to this angle right here. They're saying that it's congruent to KJL. Well, that's the opposite one. Those are not congruent. This one's saying the 2 angles right next to each other. So if D and C are congruent, then A and B have to be congruent. When we go to B, it's saying JLM and KJL. So I'm going to look at the middle letters. So they're saying L and J are congruent to each other. Well, we know that's not true, so we're not even going to look at the next one. When we look at C, it says K and L. Well, K and L, those are congruent according to our theorem. And then when we look at this one, it's referencing the J and M. And J and M are congruent. That's why the answer is C. So now we're going on to the next part, polygons. A polygon is an inscribed polygon if all of its vertices lie on a circle. The circle that contains the vertices is an inscribed circle. So it gives us the 2 examples. Make sure you pause and put that in your notes. Same thing with the next theorem. Pause and put it into your notes. Theorem 10.9. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle and the angle opposite the diameter is the right angle. So it's saying that the measure of ABC is 90 degrees. So this angle here, B, is 90 degrees if and only if AC is a diameter of the circle. So for this theorem to occur, the hypotenuse and the diameter are basically the same thing in the circle. I recommend that you go to myhrw.com and look at example 4. It's an abstract problem. Don't really deal with any number values, but it would be good for you to look through it. So here is our next theorem, inscribed quadrilateral. Only certain quadrilaterals can be inscribed in a circle. And then it refers to theorem 10.10. Theorem 10.10 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So opposite angles. So E and G are opposite. They have to add up to 180. Same thing for F and D. They have to add up to 180, supplementary. So now we're going to do example 5. So I'm going to draw first circle with our quadrilateral inside. Oh. So Q, R, and P. So here's my circle. I'm going to zoom out a little bit. I'm going to put in the values that they gave us. So this is 80, 75, Y degrees, and X degrees. So it wants us to find each value. So here's our first one. So to find X, we're going to look at the opposite ones. So according to our theorem, it says that these two are supplementary. That means they need to add up to 180. So if we make an equation out of it, X degrees plus 80 degrees is equal to 180. Obviously, you can do that in your head. Minus 80. X is equal to 100 degrees. Now to find Y, these two are also supplementary. So that means they have to add up to 180. So Y degrees plus 75 is equal to 180 minus 75 minus 75. 7, 10, 5, 105. I'm sure Drew did that in his head in 5 seconds. So Y degrees is 105. And let's see. And that's it for 10.4. Make sure you watch the next video of 10.5. Bye, guys.